Moving on to the next question, we're going to solve for secant theta is 2 over root 3 in the domain from negative 2 pi to 2 pi. One way that I would maybe ask you to consider is that this domain can be broken up into two subdomains, and that is 2 pi to 0, if you want, or 0 to 2 pi. And if that helps you think of things better, you can break this down into two questions. But if we start at negative 2 pi, which is right here, negative 2 pi, and we move in a positive direction, so negative 2 pi, that would be negative 3 pi. Sorry, incorrect. Let me say that again. This is negative 2 pi. This would be negative pi, 0 pi, and then 2 pi as we go around the circle. But regardless, let's get started on this. I need to work on this trigonometric ratio. It's the reciprocal trigonometric ratio, so I may want to change it to the primary trigonometric ratio. So secant theta is equal to 2 over root 3. Fair enough. By definition then, I could take the reciprocal of both sides. So I'm going to solve this two ways, and number one would look like this. Well, by definition, I know that secant is equal to 1 over cosine is 2 over root 3. Good. And then I could take the reciprocal of both sides, and therefore cosine theta is equal to root 3 over 2. Alternatively, I could just move straight across. I could ask myself, what is the reciprocal of secant? Well, that's cosine theta. What is the reciprocal of root 3 over 2? Well, that's, the reciprocal of 2 over root 3. That's root 3 over 2. Regardless, we end up in the same position, don't we? Cosine theta is equal to root 3 over 2. So I'm just going to delete all of this, give myself some space. Now I'm going to mark on my unit circle. Now it doesn't matter how many angles I include. Really, I'm just wondering where the cosine ratio is root 3 over 2. Well, that's pretty close to 1, isn't it? So your cosine is root 3 over 2 is going to be very close to this spot right here. So we are working in radians. So I suppose if I was to name that family, I would name that family pi over 6. So how many angles are there in these positions? From negative 2 pi to 2 pi. Well, negative pi over 6. Now, how did I get that so quickly? Well, perhaps I know that this angle right here is 11 pi over 6. If I reflect it, it'll be in this position here. Also, negative pi over 6. Pi over 6 and 11 pi over 6. Chances are, it is not the latter two that give you difficulty. Also, if you're having difficulty with this, perhaps you're not. What we can do is we know that this is in the position. Let's talk about what is the negative angle here. Well, we know it's in the position of pi over 6. And if we simply subtract 2 pi, we get negative 11 pi over 6. Also, this angle right here is in the position of 11 pi over 6. Now, if I want to find the negative coterminal angle, I could just simply subtract 2 pi. Regardless, if you do that, you end up with negative 11 pi over 6, comma, pi over 6, negative pi over 6, pi over 6, sorry, that should be 6. and 11 pi over 6. There we are. And that's theta. So I'm almost done here. We're heading for home. Last example. This lesson has definitely been challenging. Whew. All right. Suppose phi lies in quadrant 4. By the way, this is just a fancy angle, right? Phi lies in angle or quadrant number 4. Oh my God, I'm going to draw this picture once again. I don't know what we're talking about, but it's in quadrant number 4. There's a point on its terminal arm. It has the primary trigonometric ratio of 4 over root 27. Fair enough. We want to determine the exact value of cosecant phi. I'm going to solve this two ways because I'm fancy like that. Well, I know that cosecant phi really can be represented by 1 over sine theta. So if there is any way that I can think of or get the sine value or the sine ratio, sorry, not theta, it should be phi. If there's any way that I can get the sine ratio, all I have to do is take the reciprocal, and that's the cosecant. If you recall, I know that sine squared theta plus cosine squared theta is equal to 1. So very simply, if I plug this in to there, I should be able to figure out sine. So, and we know by looking in quadrant 4 that sine is negative. So that is something that we have to work at. So sine phi is negative. So, all right, let's get started. So I'm looking for sine. So sine squared theta plus 4 over root of 27 squared is equal to 1. Sine squared theta plus 16 over 27, if I square both top and bottom, is equal to 1. So sine squared theta is equal to, so I'm going to subtract 16 over 27 to both sides. I believe this is 11 over 27. All right, so sine squared is equal to 11 over 27. So therefore, sine theta is going to be equal to plus or minus the square root of 11 over the square root of 27. And since we know that sine is negative, we can for sure reason that this has to be negative. Therefore, the cosecant is just simply the reciprocal of sine. The reciprocal of negative root 11 over root 27 is the root of 27 over the root of 11, and it's negative. All right. Alternatively, what can I do? I can make a similar triangle. Great. So I'm just going to draw a triangle here. I know that the sine value has to be negative, so that's all good, but I can just start off with a similar triangle. It's going to be a right angled triangle. And we know that cosine, so katoa, it is going to be the adjacent over the hypotenuse, right? That's cosine. I'm going to call this phi, sure enough. So if that's phi, the hypotenuse would be the square root of 27, and the adjacent side would be 4. I could algebraically solve for x. And what I get is a squared plus b squared is equal to c squared. So now 4 squared plus this x squared is going to be equal to the root of 27 squared. Very quickly, what I can figure out is x is going to be plus or minus the square root of 11. So, and we know, maybe I'll just keep it that way. So now I can say that this is the square root of 11. But we have to recognize that sine is going to be negative in quadrant 4. Now, cosecant, I could define cosecant as the reciprocal of sine, and sine was opposite over hypotenuse, so it's going to be hypotenuse over opposite. Fair enough. So that is why it's going to be the root of 27 over the root of 11. And just keep in mind that it's negative. So the use of a similar triangle may be beneficial. Similarly, you could say cosecant theta is equal to 1 over sine theta. And when you take a look at that triangle, sorry, this should be phi, not theta, 1 over the sine, sine was opposite, it's the root of 11 over root of 27. Regardless, end up with that as an answer. Hope this helps. Wow, glad to see this lesson in my rearview mirror so I can practice